Dear webinar participants, my name is Matthias Schein. I'm Managing Director and co-founder of CGS Labs company. I am civil engineer by my profession. I enjoy my work since our beginnings 30 years ago, and I hope that our products and services express all the passion and enthusiasm of our CGS Labs team. Let's start with today's webinar. Today, me and my colleagues Matic, Valentina and Antonio will present you 3 CGS Labs products for civil engineers and road designers. These are Plateia, Autopath and Autosign. This CGS Labs team photo was taken in Planica, which is one of the most famous places in Slovenia, well known for its ski jumps and world records. Our headquarters are located in Ljubljana, capital city of Slovenia. And by the way, the team on this photo is not complete because some of our colleagues are sitting in our offices in Germany, United States, United Emirates and Serbia and couldn't join us at this occasion. Looking at this world map, you can see that CGS Labs software is used in many countries all over the world. We closely cooperate with our resellers and partners who can provide you first-class support for CGS Labs products. CGS Labs software portfolio consists of 6 products. Plateia is our flagship product, developed for more than 25 years. Used for designing new roads and for the roads reconstruction or rehabilitation. Autopath is our swap path and simulation software. With it, you can simulate driving maneuvers for standard or complex vehicles. Autosign is the solution for traffic signs and road markings. As you will see later during today's webcast, Autopath and Autosign can be integral part of Plateia software. Ferrovia is our solution for railway design and reconstruction, while Aquaterra is the software solution for river engineering and flood protection. Last but not least, Electra is our solution for electric overhead power lines design. All our products run on top of AutoCAD, Civil 3D or BricsCAD. We are constantly developing and improving all our software products. Today, building information modeling is more and more important for the design, construction and maintenance optimization. And as you will see, CGS Labs products integrate traditional design methods with the latest BIM technology. I suggest to have a closer look at Plateia, our roadway design software now. I will ask my colleague Matic to present the product. Please, Matic.
Thank you, Matthias, for this clear presentation. So let's proceed with Plateia. Let me introduce myself at the beginning. My name is Matic. I'm a technical sales engineer here at CGS Labs. I'm a master of civil engineering by profession, and I also play a guitar and write songs in my spare time. Let me introduce also Plateia. Plateia is a BIM-ready solution for roadway designing and reconstruction. It's a full-covered civil design tool for all kinds of roads since 1993. You know, we have been here a long time, so we know a lot. So let me introduce you this very fine software. Its fields of use are mainly highways, urban roads, urban planning, racing tracks, earthworks, intersection, roundabouts and so on. It offers a great complexity and capability for designing all types of roads and new roads and reconstructed. Also for all design stages from conceptual designing to construction and 4D and 5D analysis and so on. We will show some basic capabilities through our technical presentation in the next slides. So let's start with a technical presentation. At the beginning, I would like to show you a quick workflow with only 10 major steps that will take just around 9 minutes. Just sit back and enjoy. So we see Platea working on the civil 3D at the beginning. I will get some input data through Google Maps import. So I've just selected some unknown area in Riga. I've never been there, so I don't know this area. This is just for the presentation. So with a few clicks, with the right coordinate system, I got the right elevation points in my drawing and also the image, the underlay image. So I will hide it for a second here. In the next step, I go to layout. We define the axes that we will need here. So their names are axis 0 and axis 1. You will see later why. And in the next step, I create digital terrain model. So this is the basis of all other steps. So with a few clicks, there is our terrain drawn here in the drawing. So I go back and I can start drawing alignment. So you know those methods like tangent polygon, draw with stick method, with best fit, it doesn't matter now. I select tangent polygon, but first I will get my underlay back so you can see where it fits. So I start with the first axis. I just draw it straight ahead through the first road. The Platea will calculate everything for me. I select the second axis, which is called axis 1. I go also for tangent polygon, and I draw a straight line through this street. I'm not sure how it's called, but you got the point. So now we have two axes here. I put also the sample lines which will define the later created cross sections on those lines. So for both axes I define sample lines. In the next step I drape them. So the sample lines are now in 3D projected to draped into DTM. The next step is going to profile section, and the profile section will define a table where I should define the tangent, the profile of the road. So just for example, I draw here a simple profile and calculate super elevations with a few clicks, and we got super elevations in the table. I repeat this step for the axis 1. I go to draw profile view, I put it in my drawing, I add the profile of the road, just a sample one like this, and calculate super elevations. So now I'm ready for the next step. The next step would be the cross section, defining cross sections. I have to first input the cross section tables like in drawing, like here, but I will put it a bit nicer, like for example here. And these are cross sections for the axis 1. You see, I have a table, I have drawn the terrain in the cross sections, and the lanes are also in the first step defined. I add here for the second axis. I select axis 1 and I go for a powerful tool that is called macro. That's like subassembly library, which are predefined cross sections like here. And with a few clicks, I got the geometry of the cross sections. But now I also need to define materials. So like this, it's very simple, similar to hatch, but it's not. It's intelligent hatch because it has some data behind it. So I define the layers of the pavement like this. I repeat once more, and the lower layer would be like base, for example, with some different method. And like this, it's simple. I just select the edges I want to hatch. I want to define materials here. So like this. with a few clicks, I've defined the cross-sections geometry. And I will have to repeat this for the second axis. I go for macro, that's like a script which is predefined cross-section. So I selected the same type of the cross-section, and now I will repeat the steps I did before. So I have to define all materials in the cross-section. I go for asphalt. I select the top edge of this asphalt, which are lanes. The second layer would be binder course. This is under asphalt, is the second layer, and the last one would be base. So I go the same procedure. I will show the program which edges are my layer of the base, like here, and enter. So I've defined the cross sections for both axes, and the last step would be to create beam model just from the 2D geometry. As you saw, with a matter of one click, I got the first beam model of the first axis, or the axis 0. And I will do the same for the axis 1. I click draw, and based on the predefined materials, the beam model is created. But there's some strange thing, because there's no intersection between those axes. So I will just hide this selection here, and I go back to layout section. And there is a very beautiful command called draw intersection, which will draw automatically the intersection for us with a matter of few clicks. I do some fine settings, not much, but I try to do just default as it is. And now I have to wait a few seconds while the program calculates and draw, as you see in the drawing, how everything is drawn automatically. So this is some very basic intersection created. So I will hide so you can see it better. So this is the whole geometry, the whole beam geometry, 3D model, which can be then simply exported when working on some collaboration with other designers, like on beam level. So I will export everything from here. Yes. I select manually which objects should be exported into IFC. So in my case, all the 3D solids of the roads and the intersections. So now let's see this in some external viewer, like in Beam Vision. Beam Vision is some free viewer for IFC. So here it is. That was the 10th step with a few detailed modification. Let's proceed. Let's see a quick program structure. You saw that I went through layout, profile, cross sections, auto sign, not here, AutoPad, not here, but through Beam also. Why not through auto sign and AutoPad? They are standalone products that will be presented a bit later. But here I want to share with you that we have Platea program divided into 3 packages. So the Platea standard will enable you that you define the whole geometry with only 2D and also 3D level. Platea Professional will add that auto sign, so you can design the traffic signs and road markings. And Platea Ultimate will enable you that you upgrade everything to Beam that you saw earlier, and also will add AutoPad as a standalone software, which is for swept pad analysis. If we go also how the program is structured inside the platform of a civil, it also works on BricsCAD, but let's concentrate on Civil 3D. So you saw earlier that I went through layout, profile, cross-sections, utility. The first is layout. It has all tools like defining the project, defining your axis, defining your input data from surveying and so on, creating a digital terrain model, defining the whole geometry of the alignment, defining cross-sections and roundabouts. The second ribbon would be profile, which also enables you a lot of powerful functions like best fit method for defining your tangent in profiles and calculation of the super elevations. That would be also very useful. Draw a mass haul, so when calculating mass haul across your stations. Cross sections you saw that has a powerful command here. It's called draw macro. So macro is are like scripts, predefined scripts for defining your geometry of the cross sections. So you can do everything manually from a line to a line, but you can also do it automatically. You define all the materials as you saw earlier, and through the defining all of those before, you can create your 3D model. You can export it through IFC. You can share it through this translator of Civil 3D, LandXML, Oxtra, and you can also export it through to Google Earth, which we'll show it a bit later. Let's see some example here on a local road. We will see everything more detailed. We start with a layout with some powerful tools here in this section, like best fit alignment method, Google Maps underlay, Google elevation points, and so on. So we start with the find project here with the first command. We name it like, for example, ENG. We click OK. We have all the data about the project here, and now we can start. We need some input data like points, like survey points. We have here some basic example. So I select X, Y, Z example. We see the points are inserted here. I select a layer. We name it like 0 minus survey, for example. Click OK, and the points are inserted in the drawing. But now we don't know where we are, so we need some underlay, which is very easy to get with Google Imports command. Like here, I click on satellite, we click find the location and the right coordinate system, which is in Slovenia in this case. I click back on satellite. I got the orientation right. I deselect import elevation data because I don't need them, because I have survey data there. So I have my underlay here, which is very useful. So I put it behind, send to back, and now we see all the points. In the next step, we have to create some digital terrain model, which is our underlay for defining alignments. So we name it test. We select the input data, which are in this case those points that we inserted them earlier. Draw triangles boundary. Okay, and now here is our DTM. But we have some bad points there. So I will just deselect them in this case from DTM. I click OK, and the DTM looks good in this case. Go on top back. Now we see, let's hide this DTM. We have points, and we have underlay, and I will draw with a simple polyline my conceptual alignment that I will define later with our powerful tools. Now we have polyline. I will select best fit method. So the alignment will be created based on a polyline that I draw earlier. So But before I have to create the name of the axis, so this axis will have all the data stored inside this record here. This axis has data about road function type, and based on those selections, the parameters and the standard behind it will be calculated later. So the horizontal elements will be based on those selections, so based on which type of the road we have. So best fit alignment method works very simple. We just select the polyline and click OK, and we have calculated the first result. So okay, with some modification we have like result like this. Here is our regression analysis result that will show you how result complies with the input data that was polyline. But I'm not satisfied with this result, so I will do everything from now manually. I will insert a point in a tangent polygon and I will drag my alignment around so it will fit best to my expectations. So even that is not good. So let's do some more modifications. So I repeat the command move pi and I go a bit higher here. So I click OK. Now the high top is okay, looks good. I move the lower top. I click OK. Now we are very close to our expectation. So the last step I think would be like here, like this. I click OK and it looks quite good. And it will fit for now, so we can proceed from here. So we've created the layout section and now we can proceed to profile. Profile section enables you to use some powerful tools for defining best fit tangent method like here. It will fit perfectly to your existing terrain or the road, which is very useful when we are defining reconstruction. So let's see it. I select project. I select the same name project, so we are working on the same project. And as you can see also that I'm working on a fresh drawing here. That is very useful because designers are able to draw different sections of the project in a different separate DVGs. We just connect everything through input data from, for example, layout, profile and cross sections, and through the name of the project. So my input data is layout here when I'm trying to define profile. So the program will grab everything from layout, like here. I click OK. I define the point of insertion, and I got the table of the profile with all relevant data. And you can see at the top also the existing or the created DTM. So I will just define my best tangent. I can do it manually like here, like profile, but I will choose best fit method. That goes with reconstructions because it will follow the line of the terrain the best, like here. It works very quickly. I have to wait a few seconds, and now I got with the violet color. You see, this is my tangent of the road, and here left you see also the same regression analysis result that can show you how the offsets are working here. Are they good or they are not? So you can do everything manually. You can edit everything manually from here, but I think it's good for now. And the next step, I will have to define super elevations like here with a matter of a click. So I go back to the layout. Now, once I have tangent defined and I have calculated super elevations, I would like to see everything in 3D. That's some kind of logical. So I go to layout. Draw roads in 3D. And what will happen is lanes, the left, the right lane, and the axis will be translated into 3D. So I select the profile DVG. Always I have to show the input data, which are in this case saved in profile section. So now you see lanes and axes are drawn in 3D. Cross sections will give us geometrical information about the parts of the roads, sliced parts of the roads. Powerful tools in the program Platea are macro editing. Those are like called scripts, similar to sub-assemblies in Civil 3D. They are predefined libraries of the roads, so of the cross section of the road, so you can use them, and they will create a cross section in the matter of click. You have all other detailed editing tools also available, and the quantity takeoff. So once you're done with your geometry, you can pull your quantities from this command here, and you will get everything written into outside file or inside the drawing itself. So let's see how it works. We are again in a empty drawing. I select the input data from profile and layout that has to be somewhere outside, and the program then is able to read everything from them. And here you go. We got the table of cross sections here. So there is a table with terrain and lanes drawn inside. So we can draw everything manually from every single line to the last one, but let's show some in between. We won't go with a predefined library, but we will define layers of the pavement separately. So at the beginning I will go with, for example, asphalt. I'll go with 5 centimeters and I will define this as asphalt as a material. I click OK, and I have to show the program where should I put those materials under the lanes, and we have defined the width of the separate layer. I repeat this command for the next layer, so I will go with binder. I go 15 centimeters. I select the material, binder course. I click OK. And I can select manually from which to which cross section I would like to edit this procedure. So for now, I'm just editing only the first cross section. As you can see here, only the first one was edited. So like here, you see only the asphalt is here, but I can select the random cross section, and I will tell the program to go through all cross sections. Like here, I will show the lower edge where I should put a new layer, and you can see the program was now able to draw the layer under all cross sections in the table. I can go back. I will show you something else. We are now at the beginning. We have only lanes defined here, and I go for macro. These are predefined cross sections here. I select, for example, demo or TCS basics, and I will go through all cross sections. I click OK, and in a matter of seconds, we have defined all cross sections. With just one click, with one predefined library. And the next step would be to define materials to this geometry. I can predefine also the materials, but here you can see I define the geometry separately from the materials. So in this step I'm defining materials to the first layer, the asphalt. The next would be, for example, binder course. Okay, I go under asphalt and I click and I got the layer with binder course, and the last would be base, and I can define everything with the different method, like very similar to hatch. You know, we are working inside Civil 3D and you are familiar with all those AutoCAD functions. This looks very similar to hatch, but it's not. It's some kind of intelligent hatch that has other data saved behind. So I will save everything into new file. I click I will override this old file. Okay, I click yes. And now we are prepared for the last step. So I've created a new drawing. I set myself to the old project and I will draw a 3D model out of those previous data. I have to show the program where is layout saved. Here, profile is here, and cross sections are in here. And the program will automatically read from them which materials are defined and all the geometry from the files. I click OK, and now I got 3D model here. That's a sample, very basic sample, but it works like charm. If I go to realistic look, you look even better how the materials and the layers are well defined here. So I would like to add a new layer. If I need this to do later, I can just go to cross sections. I will add some new layer, like, I don't know, fill for example. And okay, I have to select a new name, pavement 2, and I will add a layer under the existing layers like this. So now I have a new layer added. I click save and I go back to my 3D model drawing, and here has nothing happened yet. So I go to utility, I click draw 3 model. Once again, I select all the previous data. Now you see the fill is automatically added here, and I will not erase the entire model. I will just add it, and you can see with just a one click, I got this layer added here in my drawing. So my new 3D model has a new layer, and it's ready to be exported or anything else. Speaking about BIM, Platea will enable you to use BIM tools like some kind of hybrid technology, because you can work everything classic way, like 2D, 3D, and then you can upgrade everything into BIM if you need it. So we have some integrated powerful tools like Import IFC, which enables you to import everything from other projects which are saved in IFC and import it into your drawing here into DVG. You already seen that we also enable export IFC into 2.3 or 4.2 version. And there are some very useful tools like Google Earth export, so we can show to everyone how it looks, your model into real area. And also the second powerful tool, which is not here, is Google Import, as you saw at the beginning. So let's see how it works. This is the end version of the project that we've been working on earlier. So this would be the end model. So if I go, this is the first stage, and this is the end stage. But I would like to show you how to share those information from the end version through IFC into my conceptual stage. Like I will save it everything here to IFC, and I will just select some parts around the intersection. I would like to import that end version of intersection into my first version into layout. Look how this happens. I go to layout. I will hide this object so you can see better. This is my first conceptual version. And you see, I only have my alignment here, but now I go to IFC import, and I will import that IFC that I've saved earlier, and you can see it right here now. So that intersection is now here in a shape of solids. So you can work everything from here like with normal objects. It's not like IFC, they are like solids. So I think this is very useful when working with BIM and sharing information across your project and between your team members. And just for the end, I would like to make some conclusions and take out some advantages of Platea over the competition. Overall, we can say that it has industry-proven workflow, which is straightforward and very easy to understand. That's why it's also fast to learn. It seamlessly integrates with your working process, and it's all-in-one tool. So that means CAD and BIM tool is all in one. You don't need other plugins to design a road. From a technical point of view, we can say that the shortest way has only 10 major steps to design a roadway geometry, as you saw at the beginning of my presentation today. It has integrated powerful functions like best fit alignment, best fit for tangents, intersections, you saw it, roundabouts. Traffic signs and markings are part of a standalone product called AutoSign that you will hear later, and also swept path analysis, which is also standalone product called AutoPath that will be presented next. Platea has possibility for manual cross-section detailing, so you can provide paper designs and plans to contractors, which is still very useful today. It has capabilities for data exchange within IFC, LandXML, Civil 3D, Augstsprieguma, and others, and that is very useful when working on the same project with different team members. It enables collaboration, so projects can be divided among team members. They can work simultaneously and split the same project into several drawings, as you saw in my presentation. And one of the brightest advantages is also that BIM is not an obligation, but it's an option. So you can do it everything classic in 2D, or I can say 3D, and you can upgrade everything at the end to the BIM level and export it through IFC, and then collaborate with a project that is on a BIM level. So that will be all from my side. I thank you for your attention. I welcome our Miss Valentina to present you our next product, which is called AutoPath, and have a nice day.
Thank you, Matic. Hello to all of you who are attending this webinar, and welcome to the presentation of AutoPath. My name is Valentina Brichko. I'm a civil engineer by profession, and I'm AutoPath technical sales specialist here at CGS Labs. Today we will learn about what AutoPath is, what is it that it enables, and how it can simplify your designing process and save you a lot of time. So let's dive in.
AutoPath is a professional software solution for vehicle swept path analysis used by civil engineers, transportation professionals, architects, urban planners, and many others who use it to analyze vehicle maneuvers on roads, parking lots, construction sites, at airports, loading bays, in warehouses, or whenever they need to validate a design, plan special transport, or are simply not certain about vehicle clearances. AutoPath offers you tools for vehicle swap path analysis, animation, and reporting. Different methods are available for horizontal and vertical swap path analysis. You can select between a large number of vehicles that are included in the software. You can customize vehicles or design your own. You can customize the software by setting various general and advanced parameters. You can create animations and different reports for each created swap path analysis. It allows you to import Google Maps data, getting started videos and software tutorials, support, access to updates and upgrades, and help documents are easily accessible through AutoPath Ribbon. To make these features easier to imagine, let's look at some of them within a live demonstration of the software. To facilitate the swap path analysis process, AutoPath already includes a list of predefined country-specific vehicle design libraries like ASHTO for the United States, Canada, and Middle East, libraries for Australia, New Zealand, UK, Germany, and also libraries of specialized vehicles like emergency vehicles. With custom vehicle design options, users can extend these vehicle libraries or create completely new specific libraries of vehicles that are otherwise not included in the software. AutoPath allows you to define a comprehensive set of vehicle parameters, enabling them to design from a simple to highly complex specialized vehicles with multiple axles like forklifts, cranes, and so on. To create a new vehicle, you can select Add Vehicle icon on the ribbon, or simply edit vehicle in the library that you have chosen for your base vehicle. Enter the name of the new vehicle, then you can preview all parameters of your new vehicle and customize them. You can simply add specific load shape to an existing vehicle or vehicle trailer, set advanced vehicle definitions, and design horizontal and vertical contour of the vehicle. When you are finished editing these definitions, click OK to confirm new settings. For creating horizontal and vertical swap path analysis, different methods are available: interactive, place adaptive, and manually guided. EasyDrive is an interactive method for creating horizontal swap path analysis. After starting the command, you first choose the type of vehicle you want to use in the analysis. When the dialog box opens, you can define variables for speed, friction, super elevation, and minimum radius. In this dialog box, you can also check the parameters of the chosen vehicle, or change default settings for current swap path analysis. For example, set the turn prediction on or off, select color, line type, and so on. After completing the settings in the EasyDrive dialog box, select the starting point and direction of the vehicle in your drawing. Then simply add points to the vehicle path by clicking on your drawing, which will create your interactive swap path analysis. Turn Predictions preview helps you see the next possible maneuver. As you can see, there are turn predictions in all directions available in AutoPath. With the Horizontal Analysis feature, you can perform swap path analysis based on the selected line object. New Swap Path Analysis dialog box opens, where you select the type of vehicle you want to use in the analysis. To create the vehicle analysis, press OK and then select a polyline, 3D polyline, or alignment defining a vehicle route in your drawing. The swap path analysis will be automatically applied to the line object. You can do basically the same thing in vertical direction. A vertical analysis feature allows you to check a vertical vehicle movement, which can be very useful for evaluating transportability of road underpasses, garage entrances, and similar situations. AutoPath automatically creates a vertical path analysis, and in this case we can see that it has also immediately reported some ground conflicts. You can easily resolve conflicts by making adjustments in the design. Since vehicle route is defined as polyline, 3D polyline, or alignment, you can simply edit the analysis by moving the grips of the line object. As you can see, the analysis updates automatically. If you want to detect the horizontal or vertical conflicts between the swept path analysis of your vehicle and surrounding infrastructure, you can also do it with collision detection tool. You just select the object you want to verify the possible clashes points with, and then select your swept path analysis. The software will detect collisions and mark them. When you identify your potential obstacles, you can adjust the vehicle path through manipulation of points along the travel way to create a vehicle's route without conflict points. After editing the swept path analysis, the collision detection will be refreshed dynamically and collision marks will disappear. In case you didn't manage to resolve all of the conflicts by editing of your path, you can further visually inspect which part of vehicle is colliding with the help of animation. You can animate any swept path analysis created with AutoPath. To run animation, click on the animation icon, select swept path analysis you want to animate, and click on the play button. In the dialog box, you have several options for controlling your animation. With control buttons, you can pause or stop your animation. You define the speed of the vehicle at the beginning or change it later during the animation. During the animation, you can also draw a vehicle in its current step to see its accurate position in a specific moment. And there is also an option for drawing or deleting entire vehicle trace. There are also options for settings of the vehicle path analysis and for showing the vehicle parameters within the animation dialog box. And animation can also be run by moving a control button on the vehicle's path left and right. AutoPath provides a range of swept path analysis reports, like horizontal and vertical vehicle contour and parameters display, collision detection, a white labeling option of the swept path for the inspection of maximum white values, and many others. The report command even enables you to insert a graph of a vehicle turning angle into the drawing. And the best thing about this report is that it's dynamic, and you can change your swept path analysis at any time you want, even after you created turning angle report. For example, when you want to resume existing easy drive analysis, you can do this with Continue Easy Drive by choosing your swept path analysis you're creating before. Continue Easy Drive feature enables the smooth continuation of the analysis. However, with adding new points, the route changes, and as you can see, so does the turning angle. Another thing you can equip your drawing with is the vehicle profile image and parameters. The command vehicle profile allows you inserting a selected vehicle profile in a drawing. After you press the command, you just have to select the point in a drawing where the profile contour of the vehicle will be inserted. Below the profile is written the name of the vehicle, weight, front track, back track, average steering angle, turning time, turning circle curb to curb, and turning circle wall to wall. With AutoPath, we have a feature that is not integrated in any of competitors' products. This is Google Maps import. It provides unique raster imagery and elevation data insertion options and street view capabilities within the CAD drawing to help clients, investors, or the interested public to visualize areas where swept path analysis are taking place. You can import Google Maps raster and elevation data into drawing with just a click. After selecting location, adjust zoom to the desired area to be imported. Check whether you want to import raster data, elevation data, or maybe even both. And after selecting Import, choose the appropriate country-specific coordinate system. As you can see, AutoPad comes with an extensive list of supported coordinate systems worldwide to enable convenient data insertion. By clicking OK, data is seamlessly inserted into the drawing. This feature can be very useful for special transportation planning or in case you have to figure it out how you will deliver crane on the construction site. So in cases you have to rely on the existing infrastructure. But of course you can also use it when designing your project from scratch. For the end, let's summarize what we have learned in this session. The key advantages of AutoPad are integrated Google Maps import, especially useful for special transportation planning, dynamic reports that update automatically while path editing, next maneuver previews available in all directions, supported the design of your own vehicles, even with multiple trailers, and some other advantages were presented in the technical part of the presentation. AutoPad is also very easy to learn. Feedbacks from our customers are that it takes you 15 minutes to 1 hour to figure out the designing workflow, and so easy to use that even non-engineers, or let's say people without engineering background, are able to design with it. Those of you who are using AutoPad at the top of Civil 3D and are familiar with Autodesk vehicle tracking or other similar software solutions for creating swap path analysis, you may know that those products are a bit more complex to begin with, especially the part of creating customized vehicles. The other advantage of AutoPad is that it is available with no additional cost, since all vehicle libraries are included in every version. I would also like to take this opportunity to invite you to subscribe to our new AutoPad blog. In this blog we will discuss the theoretical background of swap path analysis alongside research from the field, areas of application, real study cases, and so on. We will present software tools and functions that seem particularly relevant and practical, along with the tips on how to successfully use them. We intend to present also new releases of AutoPad software, as well as all other novelties such as new vehicles, updates, and so on. If you may have some specific questions related to AutoPad that you would like to be considered on the blog, I invite you to share it with me. My contact details are listed in this presentation. Feel free to contact me anytime and subscribe to the blog as soon as possible. Thank you all for your attention. That would be all from my side, and now let's hear about AutoSign from my colleague Antonio.
Thank you very much for the introduction, Valentina. Hi everybody, my name is Antonio Ibañez. I'm technical specialist for infrastructure software at CGS Labs, and mainly my work focuses on the development of AutoSign. I hope you enjoy with this presentation.
So let's start with a brief introduction about AutoSign. AutoSign, what it is? AutoSign is a software solution for planning, traffic signaling, design and management in both 2D and 3D on CAD environment. AutoSign mainly it's a product by itself, but it can be included as part of Platea. AutoSign mainly has two different products. AutoSign Professional focused on the 2D functionality, and then AutoSign Ultimate, which beside the 2D functionality as in Professional, it also includes the 3D and BIM functionality, which makes the Ultimate product. And let's take an overview of the ribbon of AutoSign to see what it looks like. We have a library manager. Then we have two commands on the vertical signs. We have the pavement markings. Then we have the reports with extra order information. Then we have a set of tools. And up to here is AutoSign Professional. After this, we have the 3D functionality, the Google Import and Google Earth Export, the Bing functionality, and a set of utility to improve your experience with AutoSign. After the overview of the ribbon of AutoSign, let's get into the technical presentation. The first topic that we are going to touch is going to be traffic signs. Traffic signs is one of the most basic and important functionality of AutoSign. It mainly focuses on the insertion of traffic signs on the 2D design. AutoSign has available several signaling packages based on national standards. Here I expose some of them, as for example ASHTO, Slovenian, German library, and also we are developing much more, as for example the Lithuanian one. It's important to say that we keep working on developing more and more national libraries. Second feature, very important, is the capability of AutoSign to attach the information of the alignment, and very important for these civil 3D users, because the information of the civil 3D alignment will be attached to the signs after their insertion in the drawing. Regarding the supports of the signs, we can say that there is a wide range of settings for posts, and there are several types and geometries of frames for gantries. And now let's go to a practical example. So we prepared a civil 3D alignment for our example. We are going to click in Library Manager, and we can see how we have already 2 libraries in this installation. Those 2 plus much more can be downloaded from our downloading module. Now we are going to click on the Slovenian one. This is the one we are going to use. And by clicking on traffic sign, first thing we're going to do is select the civil 3D alignment that we're going to attach the signs. We're going to filter the names, and there is 2 ways of insertion. The first one is, as you see, click on the drawing. And the second one is by inserting the station. So we're going to focus on the station. We input the station 160, and then we input the offset, so the distance from the alignment, and the sign is automatically located at that point. And now we are gonna check some editable options of the gantries. So we click on edit, and we select our gantry, and here we can change the geometry of it. And not only that, but also the dimensions, as it can be shown now. We shorter or enlarge the dimension, and automatically is changed. After the example of traffic signs, let's move to the pavement markings, the second topics. Let's see the possibilities for pavement markings of AutoSign. The first one is longitudinal markings. We can draw the longitudinal markings over polylines or over alignments. We can easily set beginning and end of the line. We can define the shape and dimension, even though the libraries, the different libraries bring predefined dimension and shapes, but also we can customize them. And of course we can attach information labels to these markings. We can also cross markings, and same as longitudinal markings, we can define the shape, the dimension, we can select the location in the drawing and the orientation, and of course we can attach the labels. The third type is arrows and other symbols. By other symbols mean word and symbol markings, and we can always select the location and the orientation in our drawing easily. Then we have a new function, coloring. By defining an area given by a closed polyline, given by 2 edges or for 4 points, we can color that area. We can set the color of the roadway of that certain area. The fifth type are ghost islands, And of course we can define the shape and the dimension, we can define the angle of these stripes of the ghost island, we can select the location and the orientation, and of course we can attach the labels to the markings. Now we're gonna check that in AutoSign. So we return to our Civil 3D alignment example to focus on the pavement markings. First thing we're gonna do is to click on cross markings. As we can see, we are working now with the Lithuanian library, and we're gonna select the pedestrian crossing and click on 1, 2, 3, and 4 points to set the boundary of the pedestrian crossing. We're gonna click now on line markings to create a longitudinal marking. We select the type, we set the dimension and click OK, and the longitudinal marking is created. Now we're gonna edit. We're gonna show that AutoSign is not only for creating, but also you can manage the already inserted signs as this one. Well, now we click on Ghost Island, we show the different dimension options that it brings. We're gonna also include in our drawing an arrow. We simply click on the arrow that we want, and by clicking on the drawing is inserted. And the last command that we're gonna check is coloring area, where, as I explained before, there are different options to define that area. Our next topic is reports. It's a very important function of AutoSign. It gives the possibility to generate traffic signs and road markings report tables. The reports include detailed description of the quantities, especially for the pavement markings, with the length and the area of those markings. The reports are not rigid, the tables are not rigid, they can easily be customized by the user. The user can add and remove columns as they want. And a very important feature, they are exportable to Excel. So even the images are exportable to Excel. So the tables report can be completely exported to Excel. So after explaining the main features, let's move to an example. Here we are working again on the Civil 3D alignment. We click on the command report. Here we can choose between the type of report we're gonna make. We can select the signs only from one alignment, and we generate our report of traffic signs. And following the same procedure, we generate as well the one for road markings. We can see here the quantities, the area of each road marking, and as I previously said, a very important feature is that these reports are exportable in Excel, and this is an example. This is the file, the Excel file of the previous report that we produced. After reports, let's pass to the next topics, which is 3D view. As we mentioned before, this is an exclusive functionality of AutoSign Ultimate. How is the workflow? So we create with AutoSign the 2D design, and then by a click of a button, we create the 3D signs, the 3D solids of those traffic signs, pavement markings, and gantries. This gives us one more advantages, which is that all our drawings will be compatible with other potential softwares, as for example Navisworks and InfraWorks. So let's move to the example. This is the button to convert all those 2D signs into 3D signs. And here we select our corridor, in our case Civil 3D corridor. And by clicking OK, we will convert all those signs on our left hand side on 2D into 3D solids. Here we can see how the signs were created on the corridor. All of them are 3D solids, and this, as I said, give us these advantages which is all our drawings are compatible with Navisworks and InfraWorks. But the 3D of AutoSign, it's not only a picture, it's not only a nice picture to see, it can be also modified. It's very useful because, as we are showing now, we can also modify those signs by clicking on their 3D solids. We select of a different geometry of this country, and this country will change in both our 3D view and our 2D view. And together with the 3D view functionality, we have beam functionality. So we managed to create 3D solids, but also we had a function to set property to those solids. Then we have also another command that identify the collision between 3D solids on the CAD environment. And of course we had 3D solids, we had properties on those 3D solids, and we are able to export them as a IFC in order to support all the BIM softwares, to be compatible with all the BIM softwares. And as we did with the previous topics, let's check also a practical example of this BIM functionality. First, we're going to focus and mention that AutoSign also includes these Google interfaces as AutoPath and Platea. And then the BIM, we have, as we said, Property Manager, Set Editor, and Property Set Filter. But we're going to focus on this class analysis and show how it works. First, we select one solid, then we select the other solid. It can be multiple selection, and the program gives us a highlighted area. That means where basically this is the area where both solids have the collision. We also spoke about IFC export, and here there is an example. Here we had a 3D sign. By clicking on IFC export, we select the sign and we create an FC file which can be easily opened in any BIM viewer. The BIM functionality was our last topic, and now I would like to point out the main advantages of AutoSign. So the first one, AutoSign is a product that it can be used in many countries and on international projects, and this is given by the chance of being able to work with different libraries based on different national standards. The second one, AutoSign is compatible with the civil 3D objects. So the point that the traffic signs, the pavement markings, the reports are attached to the information given by the alignment, to the civil 3D alignment, makes AutoSign a very useful tool for those civil 3D users. Another advantage, AutoSign is not only 2D planning, it can also create your 3D view and your 3D solids. And this leads us to the last advantage. We have 3D solids, we attach properties, and we export to IFC. So we have BIM functionality and we have compatibility with many other BIM softwares. And up to here, the presentation of AutoSign. This presentation ends the set of 3 presentations, Platea, AutoPath, and AutoSign, scheduled for today. For any other further information, please visit our official website or feel free to contact us. Thank you for your attention.
Thank you, Antonio. Let me summarize today's webinar. As you can see, Platea, AutoPath, and AutoSign deliver all the tools needed for designing new roads or for the reconstruction of the existing roads. But well, there are other products available on the market which do the similar things. Why to choose CGS Labs and our products? Let me give you some very good reasons. First, we are an experienced team and our products are well proven. Despite the fact that we are 30 years on the market, you will experience us as flexible and agile company. The main reason for selecting our products is that they are so easy to learn and use. They are intuitive and designed by engineers who learned classic road design workflows. And this is still the way how we design roads today, of course, including all the modern BIM technology. As said today, CGS Labs software runs on top of Autodesk or Brix's CAD platforms. The choice is yours, and so the opportunity to save some money. Your choice is also a perpetual license or a software subscription. And finally, we listen to your needs and answer your questions fast, without hesitation. CGS Labs software is used by thousands of users worldwide. Our references include respective companies in Central, Eastern and Western Europe, in the North America, Africa and Middle East. With CGS Labs software, thousands of kilometers of highways, main roads, local roads, city roads or even forest roads have been designed, and I'm very confident that you were driving on some of them. We are proud about it and we invite you to join our group of customers, engineers and designers. You can find more information about our company and products on our websites. Thank you very much for your attention.